So the big picture for this lesson is arithmetic sequences and series. Arithmetic sequences and series have a constant rate of change. So basically, it's the same idea as a linear function, but it's just in a series, so it's discrete. What's an example? How about a sub n equals 2n plus 5. N is the input, a sub n is the output. So in this case, we'll start with n equals 1. So you input 1, a sub 1 equals 2 times n, which is 1, and then plus 5. So a1 equals 7. The first term is 7. a2, 2 times 2 for n, plus 5, equals 9, because 4 plus 5 is 9. So that'll give you an idea of what we're doing here. So let me plot the points. It's a1, a2, and then if you were to keep going, it would just keep going with that constant pattern, that nice linear pattern there. But it's discrete. Notice that you only have distinct points, not an actual line. So in this lesson, you're going to be seeing different kind of puzzles, if you will, figuring out the rules. You're going to be given initial amount and 1 point, or you're also going to be given 2 points. So initial amount and 1 point, what if you were given, say, a7 equals 20, the d, the common difference, is 4. You would be asked to write a rule that way. And you could just use the same method as a linear function, and that's shown in the lessons. And if you're given 2 points, that would be like a1 equals 9, a7 equals 26. And then what you would do is you would kind of use the slope formula, because you would have been given 2 points, and then you would go ahead and figure it out from there. So a series is a nice formula that can be helpful for arithmetic. So the sum of the series is n, the number of terms, times the first term plus the last term divided by 2. So that's like the average of the first and last term. So let's try it for this series. And this series is in sigma notation. So what you would do, well, the number of terms is 16 because it goes from 1 to 16. And then you would find the first term, input a 1, 2 plus 5 is 7, so that's 7. And the last term, 16, 2 times 16 is 32, plus 5 is 37. And then you would simplify that out, and that would tell you the sum of the series for the 16 terms. So that's the big picture for arithmetic sequences and series.